Ivuna. Ivuna,
Yeah.
good morning. You should not be here. You should go to my math lab and do your test.
That's where I'm at right now. I can't find it.
But it is it is right there on my math lab test. There is a student who already practically finished the test.
Unit 4?
You need to go to my math lab as you do homework and quizzes and find the test. Test is there.
I see it.
Don't waste your time. Devin, same thing with you.
All right.
Quickly, because time is running.
Oh, I finished it.
You finished the test already?
Yeah.
Okay.
I couldn't find it.
It is impossible. You should find it because it is in the system on your in your assignments. If one student or two students can find, all people should find.
Are we supposed to use the 4 attempts or just one?
No, I let you use 4 attempts.
Okay.
But Devin, I just checked my math lab just a few seconds before, and I did not see your name like a person who finished the test.
I just finished it right now.
Okay.
Before I joined. It says I got an 84.67.
Okay, but you still have time. You can do that up to 11. Maybe you can try to do a little bit more, trying to get 100%.
Okay, sounds good. So are we starting class at 11?
Yes.
Okay.
Grisha, hello, are you done with your test?
Yes, I am.
Good. If you have any question, you can address to me, but at 11, I will start teaching the class. So I wait until other people finish as well. Ivona, did you find your test? Gracia, was it too easy?
Yeah, I mean, it was okay. I found some hard, but then like I tried to do it.
But if you struggled with some problems, you actually can go back because you have time until 11.
Oh yeah. I went back and then solved them.
So maybe you can try one more time.
Oh, I have multiple tries.
Yes, you can. You can use 4 attempts.
Okay. Okay then. I'll be back.
Yes. Guys, you have 4 attempts to do each problem. Ben,
Yes.
hello. You are quite a rare guest during our classes.
Sometimes.
No, but it is not how it should work because I check attendance every time. And unfortunately, the same rule works. If people accumulate too many absences, they will lose the special treatment when I drop the lowest grades.
Right.
So keep it in your mind. Definitely, it is not bad because I do the extra work recording all these lectures and sending everyone a link. But the best thing is to be here in virtual class in presence, because I can answer some questions. Maybe you can get some confusion and I can answer your question, but otherwise you just see a recorded video.
Right.
And specifically, you know that we are using the same time interval which we should use having regular face-to-face class.
Mm-hmm.
So we are not doing this at a different time bracket. Did you finish your test?
Yes, I did.
Good. Yeah, and nowadays we need to do something very unusual with what we usually do not do, but we need to survive as a nation. So, because it is a big problem for everyone right now. If you have some questions, you can address to me. So I can see people little by little coming back to our class. So if everyone finishes earlier than 11, I can start teaching the class even earlier than 11. So. And again, you have 4 attempts for each problem. So, and you still have time to use this opportunity to try the problem, which was difficult again, up to 4 times. By the way, if you have some questions about the homework for 3.1, you can ask me right now also, because inverse trigonometric functions is quite challenging material. I'm using 3 electronic devices at the same time to see what is going on. Let me actually use this opportunity to check attendance. So what kind of names I see here already? Alexia is
Here.
here. Guys, I hope you all finished your test. Ladies and gentlemen, I asked you a question.
I finished my test.
Yes.
Yes. Do you understand that you also have 4 opportunities to work with each problem? I let you use same number of attempts as I do with the quiz and regular homework assignment. So, Gracia is here. Ben
Yep.
is here. I see your names right here, not too many. This is why I'm actually looking at this side. So, Ivuna. Jessica. And Valeria.
Here.
Yes, I see. I see names of participants here on the side of the screen. The only thing when we have entire class, I prefer to do that a little bit faster. So this why I just use my roster and call your names. But at the same time, I can see that information about participants on the screen of my computer. And again, if you tried some problems and you did not succeed and you did not use all 4 attempts, you still have time to go back to try one more time or 2 times. At the same time, if you have any math question right now regarding the homework, which we started for 3.1 section, you also can ask me right now and I will try to help, because we covered not all methods in this section. I will continue today definitely solving more problems. I cannot discuss problems right now from our test because some people are still working. But the next time I will. Are you all still in California right now, or some of you moved to other states?
Still in California.
In California.
Because I'm not in California right now. This is why I'm asking. With the beginning of that card in my family, all we are reunited, we are all together. In Las Vegas. Okay, some people are arriving. So, who I see? Desiree is here.
Here.
Yes, I can see. Alexia Bush, Grisha. Okay, Alexia, Ben, Desiree. I already did that. Grisha Alarcon, yes. Ariana. Mhm. Okay, so Ariana, Kalila,
I'm here.
yes, I know. Jesus, I,
Yeah.
I see all your names, guys, on the side of the screen. People arrive little by little. We have more people already. We have just few minutes left. Devin, did you have good opportunity to do a little bit more? Devin? Cannot hear
Hello?
you.
Hello?
Devin, I said, did you go back and had some success?
Yeah.
Nice, nice. I see Demeter arrived already, right?
Yeah. Hello.
Yeah, hi. I see your names. Your names are adding on the side, on the top. I see small boxes with your names, and some people have their pictures, but the names for sure. And your names all on the side listed as participants. So we still missing some people. Okay, what time is it right now? Oops. Oh, 1 minute left. I hope everyone has an opportunity right now to look at the time. I'm showing this to you right now. It is 11. Your test was assigned for the time interval from 10:10 to 11. So I purposely gave 10 extra minutes for you because every minute is very important when you have a quiz or test. And now I'm going to teach material from 3.1. Can you hear me well?
Yes.
Yes.
Yeah.
Excellent. So let me show you the last problem, and I need to get a verification from you. Is it what we had at the end?
Yes.
Yes.
What about these problems? Problems number 37 and 38, they were both about compositions of inverse to each other functions. And here, each time when you work with these problems, you need to critically look at what you have here inside of that composition. I'm talking about these values. Like in problem number 37, inside value was 4 pi over 5. In problem number 38, it was negative pi over 10. Each time when you work with these compositions, you need to ask yourself two important questions. Question number one, in this composition, do we have inverse to each other functions or not? In both cases, for 37 and 38, our answer was positive, yes. After that, you need to ask the second question. I'm talking about asking yourselves, is that inside value of x in the range of outside function or exterior function? If the answer is yes, then that composition will be equal to that inside value of x. Like if you look at your notes, answer for number 37 was 4 pi over 5. Answer for number 38 was negative pi over 10, because both x values were in the range of outside functions. And to remind you that ranges, I will show you again this half of circles. For sine, arc sine x and arc tangent x, for both, they were a right halves of this circle. The only difference is for arc sine, it was not only the right half of the circle, it was right half of the circle, including endpoints. It was a closed interval, or we can say segment, from negative pi over 2 to positive pi over 2. But at the same time, for arctangent, even though it was, again, the right half of the circle, but endpoints were excluded, not included this time. This why it was open interval, or we can say just interval, from negative pi over 2 to pi over 2. If you look at arc cosine, you can see this time the range is the top part of the circle, top half, definitely including endpoints. And this time it was the closed interval. And let's write it in better form. Can you please, it is correct, but can you please write this in better form? Can you please adjust? I really like to have it in that form. Can you please, can you see I made it more dark? Can you please go back to this half of the circle and switch the ends? Please. Did you do that? Guys?
Yes.
Excellent. And you know what? Right now, next to each of these circles, I will write this not in the form of inequality. I will write this in the form of numerical set. So next to arc sine x, I will write r with one leg, which means the range, equals brackets, negative pi over 2, comma, pi over 2. Please find this space and write it also. You can see I just wrote it right now. It is right here. I'm talking about this. We have brackets on both ends. If we like to write same thing about arc cosine, R equals, again, both are brackets. This is right here. 1 second, please. It is right here. I'm pointing with my finger. R equals to segment from 0 to pi, or you can see closed interval. Both ends are included because we have brackets. Now, this is important because we are going to solve right now more problems using that information. Now, I'm moving to arctangent. And with arctangent, you do not see brackets anymore. You can see it is right here. And it has both round parentheses, which means all numbers between all your numbers or angles, up to you, because in using gradients, we measure angles in numbers actually. It's here, range is all angles between negative pi over 2 and pi over 2, but not equal to negative pi over 2 and not equal to pi over 2. And now I'm going to have problems from your textbook and we will solve together. The last problem which I solved was problem number 38. But I would like to solve problem right now with arctangent because I showed in 37 problem had arc cosine and cosine. In number 38, it was arc sine and arc sine. This is why I'm moving to problem number 39. Problem number 39 has arctangent composed with tangent of negative 3 pi over 8. Three pi over 8. And you need to look precisely at each of these functions and x value which you have in parentheses. What do you see here? Is it a composition?
Yeah.
Yes. Are these two functions inverse to each other?
Yep.
Good. Now, another question is, what you have here in parentheses, negative 3 pi over 8, is that in the range of arctangent? You can use rough approximation if you like. Don't forget, it is a negative angle. So you can enter this in even in your calculator. You can even use, let's say, instead of pi, you can use 180. Look, 3 times 180, which is 540, right? Got
Yeah.
it. Let's divide it by 8. You have 67.5 degrees, but it is negative 67.5 degrees. Negative 67.5 degrees angle. Is it in the range of arctangent? What is the location for negative 67.5?
It should be in quadrant number 4.
Absolutely correct. Thank you very much. Very good answer. Yes. Now question is 4 quadrant in the range of arctangent?
Yes.
Yeah. Did you say yes?
Yes.
Which is correct. So in this case, what would be your answer for that problem?
Would it still be negative 3 pi over 8?
Absolutely correct. Yes. Can you see you answered yes to all these questions and you have now very good opportunity to finish this problem like one-step solution. All other steps were verbal because you analyzed the situation. I am starting again. You ask, was it a composition? Yes. Was it a composition of inverse to each other functions? Yes. Is negative 3 pi over 8 in the range of arctangent? And you answered yes. That's it. Answer is negative 3 pi over 8. Is it clear now to everyone?
Yes.
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 But not all the time we have these type of problems. And now I'm going to move to problems where not all the time we answer yes to our questions. Very easy example, which you see here is, let's say in problem number 41, number 41. And look what you have here. Let's copy this. This what you have. Arc sine composed with sine of 9 pi over 8. And let's again ask ourselves these questions. Is it a composition of inverse to each other functions?
Yeah.
Is 9 pi over 8 in the range of arc sine? You can check again. You can do the same thing. Grab your calculators and do that research. Multiply 9 by 180 degrees and divide by 8. And I really like to hear something from you. What do you have, guys?
It's located in quadrant 3.
No, I'm talking about the value. Is it 202.5?
Yeah.
Yes.
Yes.
Is it greater even than 180?
Yeah.
Yes.
Is it in the third quadrant?
Yes.
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 Third quadrant, is it in the range of arc sine?
No.
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 And you see, no,
No.
it is not,
No.
because range for arc sine has first quadrant and the fourth quadrant. It does not have second quadrant, or let's say that quadrant. So, which means we cannot do that. But now let's see what can be done. We will be simplifying the inside portion of that composition. What you have here, you have sine of 9 pi over 8. Dear ladies and gentlemen, can I, instead of 9 pi over 8, write down 8 pi plus 1 pi over 8?
Yep.
So it will be our first step. Arc sine composed with sine. And here now I have 8 pi plus 1 pi over 8. Eight pi plus pi over 8. And I will continue my simplification because we already had similar problems. Now, instead of sine of 8 pi plus pi over 8, I can write breaking that fraction into sum of two pieces. What kind of pieces? First piece, 8 pi over 8. Is it just pi?
Yeah.
Plus pi over 8, because this 8 was in the denominator. I write purposely in quite large size that it would, can you see that clearly?
Mm-hmm.
Yeah.
Excellent. And long time ago, if you remember, I taught you the rule using your hands, like looking at this parenthesis. If we have vertical quadrantal angles, we switch to cofunction. If we have horizontal quadrantal angles, we keep the same function. Do you remember this rule? Guys,
Yes.
Yeah.
we covered this long time ago. So now, again, let's simplify the inside piece. You can see now in the next step, I just copied arc sine, and now I'm looking precisely at sine of parenthesis pi plus pi 8. Pi plus pi over 8. Is it the third quadrant? Guys, pi plus pi over 8. Do you remember it was 202.5? Is it the third quadrant?
Yep.
Yeah.
Yeah.
In the third quadrant, sine as a function, is it positive or negative?
Negative.
Negative.
So open parenthesis after arc sine and write down negative sign, because sine is negative in the third quadrant. Now, pi, is it horizontal quadrantal angle or vertical?
Horizontal.
Horizontal.
Horizontal. With
Horizontal.
horizontal quadrantal angles in this parenthesis, do we keep the same function or we need to switch to cofunction?
You keep the same function.
Keep the same function, so it will be sine. It will be sine of reference angle. Reference angle is pi over 8. This is what we have now. Arc sine of minus sine of pi over 8. So which is very good for us, but we will continue our simplification. Now, look at this box formulas in that box. Can you see the top formula which says arc sine of minus x equals to minus arc sine of positive x?
Yeah.
Mm-hmm.
What can we do now with this minus what we have in this parenthesis? We can carry it out. So it will be minus arc sine. You can see there is much more work if, let's say, that x value is not in the range. This is what we have right now, minus arc sine of pi over 8. Is it clear what happened to this minus?
Yes.
And now
Yes.
let's look at this again. First of all, continue writing equal sign and minus. Copy minus. And now let's look at the rest after minus. What do you see? Is it a composition of two functions?
Yes.
Yes.
Are they inverse to each other?
Yes.
What about pi over 8? Is it in the range of arc sine?
Yes.
That's it. So which means now we came to the last step. We have the answer. An answer here is negative pi over 8. I am done. You can see here we had much more steps with comparable with problem number 37 and 38 and 39, where we had just practically one-step solution, definitely after we answered certain questions which we asked ourselves. But here we have many more steps, which means if you answered, let's say, at the beginning, no on answer, if it is a composition of two inverse to each other functions, You cannot use this strategy. I will teach you what to do, but it will be in the next section. But in this section, you can face problems where you answered positively on the question that it is a composition of two inverse to each other functions, and you said yes, but you answered no on the question if the x value is in the range of the exterior function. You answered no. You need to have that quite long way to get the answer. But if you said yes for both questions, it is one-step solution. Was I able to deliver this message to you?
Yes.
Excellent.
Yes.
I'm going to solve. I already solved quite many problems from this part, but I don't regret. Now, it is your opportunity to ask me to solve problems of your choice. You can choose one problem out of 42, 43, and 44. And let me see what happens with people who just arrived later than others. Just 1 second, please. Bryce?
Here.
Just 1 second. Let me see. Axel? Axel?
What?
Okay. Bhaktima? Bhaktima, can you hear me?
Here.
Yeah, because I saw your name. Do we have anyone whose name I did not call? Hannah?
Here.
1 second, please. Okay. Again, last time, do we have anyone? Because I look at the names. I think I called everyone name. Okay. Which problem did you choose, ladies and gentlemen? 42, 43, or 44?
42.
42, okay. I need to grab another piece of paper because I don't have space here anymore. Can I remove this paper?
Yeah.
Yes.
Okay. You said 42, right? Guys, yeah. Okay, I'm going to copy that. Arc cosine minus 5 pi over 3 I don't have a coronavirus. I have horrible allergy here. So please don't be scared. Oh, this is that problem. Arc cosine of negative 5 pi over 3. And please answer my questions. Is it a composition of inverse to each other functions?
Yes.
Yes.
Good. Second question, is 5 pi negative 5 pi over 3 in the range of arc cosine?
No.
No.
And you are absolutely correct. Answer is no for the second question, which means definitely, it is not a one-step solution here in this problem. So we need to simplify that piece which comes in this composition in that brackets. Let's do that. What should I do? I will just simply copy arc cosine, and I copied arc cosine, and now I look precisely at cosine of negative 5 pi over 3. can you please recommend me something about that minus, which you see in parentheses?
You can drop it.
Why do you recommend me to drop it?
Because it's an even function.
Absolutely perfect explanation. Absolutely correct. Just ignore it. You can drop it without any hesitation because cosine is one of even functions. Cosine is even and secant. So drop it. So rewrite this in simpler form. Write it down like now cosine of 5 pi over 3, no minus anymore. Arc cosine of 5 pi over 3. But I will continue with my questions again. Is it a composition of two inverse to each other functions?
Yeah. Yeah.
Thank you. 5 pi over 3. Is it in the range of arc cosine?
No.
And you are absolutely correct because we can check it even using, let's say, calculator. Here we have 5 pi over 3, which means 5 times 180 divided by 3. And it is 300 degrees. 300 degrees is not in the range because our range runs from 0 to 180, right? Guys,
Yes.
Yeah.
this is the fourth quadrant angle, 300 degrees. So it is not in our range. But what can be done here? 5 pi over 3. Just number 5. Name the closest number which is divisible by 3. Which number closest to 5 is divisible by 3?
6.
Excuse me?
6.
6, right? Guys, 5. Which numbers surrounding 5 are divisible by 3? It is 3 and 6, right?
Yes.
Yeah.
But which one is closer?
3.
6.
Six.
Oh, 6.
Can I, instead of 5 pi, can I actually write that it is 6 pi minus 1 pi?
Yes.
So let's do that. Arc cosine of 6 pi minus pi on the top divided by 3. Please write it down and we will continue right now. Now I'm moving to the next step. I will write equal sign. I will write arc cosine. And now I need to copy cosine symbol. You can see what I did. But now I precisely look at that fraction. I would like to break this into 2 pieces. Can you help me please with that? What should I write instead of 6 pi minus pi, which is on the top, divided by 3? If I like to break this into 2 pieces, each top number dividing by 3. I'm ready. What I even started with parentheses. Please help me.
It should be 2 pi minus
Right. 2 pi, I wrote it down, minus what?
pi over 3.
Right. Absolutely. You had a little bit funny voice, like not being completely sure, but you gave me very good advice. Can you see what I wrote? It is now cosine of 2 pi minus pi over 3. And it is perfect. Why? Can you see in parentheses 2 pi minus pi over 3? You can simplify right now this cosine of this 2 pi minus pi over 3 using not even one method. In my opinion, the easiest way right now to simplify is using property of being periodic. Cosine, regular cosine, is it 2 pi periodic or pi periodic?
2 pi.
2 pi.
Do you understand that we can drop any multiple of 2 pi?
Yes.
Yep.
Yes.
So this is one method. So practically it means that cosine of 2 pi minus pi over 3 will be equal to cosine of negative pi over 3. This is one method. Second method, 2 pi minus pi over 3. Right? Is it
Yep.
fourth quadrant?
Yes.
Guys, 2 pi minus pi over 3. Isn't the angle in the fourth quadrant?
Yes.
Yes.
In the fourth quadrant, cosine is positive or negative?
Positive. Positive.
Positive. So which means it will be plus. Now, 2 pi, is it horizontal or vertical angle?
Horizontal.
Does it mean that we should keep cosine?
Yes.
So
Yes.
I will show right now 2 methods how to continue. This why I am pushing here, I am showing here 2 arrows to continue this problem. In the first method, I'm using property of cosine being 2 pi periodic, and I will write that continuing this problem, that it will be arc cosine of cosine, and I'm dropping 2 pi of minus pi over 3. In the second method, I'm using our rule with vertical, horizontal, or the vertical or horizontal quadrantal angles. In this case, as I said, 2 pi minus pi over 3 was in the fourth quadrant. In the fourth quadrant, cosine is positive, and reference angle is pi over 3. We keep the same function, cosine, and this what we have. Please, I really recommend you to write both methods because we will continue right now. They are both very good methods. I have even difficulty saying that one way is much better than the other way. No way, but we need to continue. First, I will continue with the second method. Look at the second line. Is it a composition of 2 inverse to each other functions?
Yeah.
Is pi over 3 in the range of arc cosine? I cannot hear.
Yes.
Yes. What would be the answer in the second method?
Pi over 3.
Right? It will be pi over 3. This is your answer. Now let's look at the top. I really do not like to see that minus, but because we have cosine, can I drop this minus?
Yeah.
So, which means it will be now arc cosine of cosine of pi over 3. And for the same reason right now, for the same reason, as I explained in the second method, the answer will be pi over 3, because I don't know if you can see that well, because I squeezed a little bit, writing in small numbers, but because again, right here in the first method, continuing, I wrote down our cosine of pi over 3, dropping that minus, and now it is a composition of two inverse to each other functions, and pi over 3 is in the range of our cosine. This why the answer is pi over 3. Guys, let's summarize what we did with these problems, because I purposely solved so many problems from this small spot. Again, if you see compositions, what kind of questions do you ask yourselves? Is it a composition of two inverse to each other functions? If you said yes, continue to the next question. Is X value in the range of the exterior function? If you said yes, that's it. What you have as X value is your answer. If you answered no for the second question, you need to simplify that inside piece up to that moment when you can answer yes, that inside value of X is in the range of the exterior function. And in this case, you can finish your problem writing down the answer. Is it clear to everyone?
Yes.
Excellent. Can I move to another spot?
Yes.
Yeah.
And now I am moving to the spot which is right above that, because I promised you to do that today. Please grab your calculators. Please have your calculators. And this is about problems from number 25 to 36. Why do we need to use calculators this time? Because the request here is use a calculator to find the value of each expression rounded to 2 decimal places. This time, actually, request is to use a calculator. So let's see what is going on here. Turn your calculators on if they were turned down. And look at the middle part, of your calculator. Find the buttons which say sine, cosine, and tangent, please. And look what you have right above these buttons. What do you see? What do you see above sine? Does it say arc sine?
Yes.
Yeah.
Above cosine, you have arc cosine. And above tangent, you have arctangent, right?
Yes.
Yeah.
That's it. But now we need to check what you have in your mod. Can you see right on the top? Can you see the button which says mod?
Yes.
Can you click on this button? Do you have that type of screen?
Yeah.
Can you look at the line number 3? What does it say?
Float.
No, please.
Radian degree.
I don't know. Can you see on the screen what I have on line number 3?
Yeah.
It says
It's
radian
different on the new calculator.
and degree, right?
Yes.
Yeah.
You need to switch to radians. You can move down to line number 3 using that arrows. It should start clicking. It is, in my case, it is already highlighted like radian. But if your degree is highlighted, move down to line 3 and move to the radian and push enter. Enter. Now my calculator is in the radian mode. And after that, you need to come back to the home screen. How? Push second button and mode button. Second and mode. And you are on the home screen again. Did you do that?
Yes.
And now let's grab some problems and solve. An example, let's say number 25. Number 25. What do I have? Arc sine of 0.1 approximately equals. Okay, let's enter how. Second button, sine button, and you immediately see arc sine and entering 0.1, 0.1, close parenthesis, and enter. And you have your answer, which we need to round to the nearest 100. So approximately 0, don't skip 0, 0.10, that's it. This is the answer. Okay, let's do another one. Let's say, is it okay if I do, let's say, number 28? Guys,
Yes.
okay, what do we have in 28? We have arctangent of 0.2. You can erase that old problem. And again, now I have empty home screen. I'm doing second button, tangent button, arctangent appears on my screen, 0.2 in parentheses, arctangent 0.2 in parentheses, push enter and round to the nearest hundredth. Can you help me with the answer? I already have my answer. What did you get, ladies and gentlemen?
Is it 0.20?
Right, because you have here 0.1973, etc. If you round to the nearest 100, after 9 you have 7, so you should increase 19 by 1 unit, so it will be 0.20. Absolutely correct. But now I would like to show you something with negative sign. Example, for negative signs in parentheses, you can use that formulas which we boxed. Where is that paper? 1 second, please. I'm talking about that formulas which we have in these boxes. Example, look at problem number 33. In 33, you have arc sine of negative 0.12. I will first apply that formula. I am going to take that minus out. It will be arc sine of positive 0.12. Arc sine of 0.12 minus is right here in the front. And now enter this into your calculator. You can immediately actually write approximately equals and copy that minus. And you can enter right now positive arc sine, so second button, sine button, 0.12, and push enter. And you are getting total in total, finally you have negative 0.12. 0.12. But number 34 is a little bit more tricky. But again, we are equipped by these formulas which we boxed, and it will help us. Look what we have here. We have arc cosine of negative 0.44. And this is not a regular cosine. This is arc cosine, and you cannot drop this minus anymore. Look at what you had in that box for arc cosine of minus x. For arc cosine of minus x, you had a formula pi minus arc cosine of positive x. Can you see?
Yeah.
So this is your first step. Rewrite this in different form. Pi minus arc cosine of positive 0.44. Pi minus arc cosine of positive 0.44. And enter this exactly as you see right here. So look what you have. Your pi is right above that button which has a corner. So it will be second at that corner, and actually pi appears on your screen. Minus, again, second button, cosine button, and this time 0.44. You enter this exactly as you wrote this on your paper. Can you see my screen?
Yes. Yeah.
Please write it down on your paper, and after that, push enter, and it will give you a correct answer. So, and what do you see here? Approximately 2.03. 2.03. Yes? And I would like, again, this is quite complicated material. I will continue next time also, but I would like to show at least one more problem right now. And this is very interesting problem from the spot from 48, excuse me, from 45 to 52. Find the exact value. If it says find the exact value, you should not touch a calculator. So, for example, problem number 45. Sine, arc sine of 1/4. It is different type of composition. This time, inverse trigonometric function is inside, but it is very similar approach to what we did before. Is it a composition of two inverse to each other functions?
Yeah.
1/4, is it in the range of outside function? Do you remember?
Yes.
Sine was fluctuating between -1 and +1. Is it in that range?
Yeah.
So what would be the answer here? 1/4. But if you look at problem number, for example, 49, let's see what we have here. We have cosine of arc cosine of 1.2. Cosine of arc cosine of 1.2. And we can start with questions right away. Is it a composition of two inverse to each other functions?
Yeah.
What, do I have only one student in my class?
Yes.
Yes. 1.2, is it in the range of cosine?
Yeah.
Can we
Yes.
have cosine value greater than 1?
Oh no.
Did you say no?
No.
Yes. Which means this problem is not solvable. It is undefined. Not defined because answer here does not exist. You can write undefined answer, not defined as an answer, or you can simply write that kind of symbol on your paper, which means does not exist. Because outside function does not have 1.2 in its range. It is ridiculous. Cosine of any angle cannot be greater than 1 and less than -1. Is it clear?
Yep.
Yeah.
Did you learn something positive, helpful for you today?
Yeah.
Yep.
Thank you. With your permission, can I end my today's lecture?
Yes.
Yep.
Thank you guys. Have a nice, beautiful day, and thank you for participating. Stay well, please. I wish you the
Bye.
best. Goodbye.
Bye.